We've all met that annoying gamer who has to swing his body and arms around while playing the Super Mario Kart on the Super Nintendo Entertainment System. With each corner he takes, he leans with his cart as if this will somehow help him take that corner a little bit tighter. Now imagine this type of player graduating to the Wii, which actively requires that sort of behaviour. It comes as no surprise that the physical accidents involving the Wii occur on a regular basis. Now the Nintendo Wii, which is the most popular next generation console, boasts family fun and entertainment. But all over the internet, the Nintendo Wii is also known for being associated with hilarious and sometimes serious accidents involving the controller. Most Wii accidents involve the remote smashing into something or somebody. Many stories abound on the internet of people running into furniture, tearing fans out of their ceilings, punching holes through the walls, and even crashing through glass tables. Then there are the accidents involving people, enthusiastic players who seem to forget sometimes that friends, family members are often standing nearby to cheer them as they play tennis, bowling, or any number of social Wii games. Players get involved in the games and forget everything else in the room. Some fault Nintendo's flimsy design with the wrist strap. Others forego the wrist strap and end up regretting it. Still others get so involved in the gameplay that they fail to notice that their hands are getting sweaty and slick, creating the perfect storm for the Wii controller disaster. Disaster and playing the Wii seem to go hand in hand. In fact, one of the main causes of accidents is a combination of drinking and Wii playing. We decided to test this assumption with some data. We looked at the number of drinks of alcohol and the activity of the Wii game. One independent variable or factor was the type of Wii game. This was classed into low activity games and high activity games. Another independent variable or factor was the amount of alcohol consumed while playing these games. And there were 3 levels. There were no drinks, there were 2 drinks, and there were 4 schooners or 4 drinks of alcohol. The dependent variable was the accident severity as a result of playing the Wii. Now it just so happens that when we conduct a factorial ANOVA, we're interested in a few things. We've got the main effects, and these describe the impact of each factor or independent variable on its own. And then there are the interaction effects. So let's look at the main effects and take the relationship of alcohol and Wii levels on accident severity. The main effect describes the impact of each factor or independent variable on its own. So to take the relationship of alcohol and Wii activity levels on accident severity scores, this is a 3x2 factorial ANOVA, in which alcohol has 3 levels, 0 drinks, 2 drinks, 4 drinks, and Wii activity has 2 levels, high activity and low activity. Now there are 2 factors, alcohol and Wii activity, and so there are 2 main effects. The main effect of alcohol, in other words, let's assume I've not measured the Wii activity levels, or in other words, I've just lumped them all together, and I just want to know the relationship of alcohol on accident severity. Then there's a main effect of Wii activities levels. So in other words, I'm not interested, let's just assume I've not measured alcohol, or I've just lumped all the different levels of alcohol together. And I just want to know the relationship between Wii activity levels and accident severity. Now the interaction effects is the extent to which differences in the levels of one factor are the same at each level of the other factor. So is the relationship between alcohol and accident severity modified by the level of activity the person's playing on their Wii? Or vice versa? Is the relationship between activity of their Wii game and accident severity modified by the amount of alcohol they've drunk? So we have 6 different groups representing all the combinations of our IV, or of our independent variable. So there are 4 people who had nothing to drink and played low-level Wii activity games. There are 4 people who had 2 alcoholic drinks and played low level of Wii activity games. And there are 4 people who had four schooners and played low levels of Wii activity. And we also had the same for people who played high activities on the Wii game. And these scores are our accident severity scores. In other words, the injuries and how injured they were. So the higher the score, the more severe the injury. So we've got 6 different groups of people, and for each a severity score for the injury. So when we do a factorial ANOVA, we'll see that we have a total variability in accident severity ratings. This is the total variability of each score from the grand mean. And then we slice it into 2 parts. So one of the slices represents the variance explained by the different groups or cells. A cell in a factorial group or a factorial ANOVA is a group of participants who are treated alike, as I said before. For example, a person who had no drinks and played a high Wii activity game. This is a variability of each group or cell scores on accident severity from the grand mean. Now for each individual in each group, they don't have the same score. So the other slice represents a variability or error among individuals within each group. It's a variability from the group mean. So we have a chunk of variance that's explained by what we do to the different groups. And we have another chunk of variance, which is the error. So in other words, that's the variance in accident severity that can't be explained. It's just the individual variability or the error that the model does not explain. So up to now, this is exactly the same explanation for how we did a one-way between subjects ANOVA, or how the variance is partitioned in a one-way between subjects ANOVA. So this is the variance accounted for by the model and the variance that not accounted for by the model. The only difference here is that the model gets partitioned up into the effect on the first factor, in this case the amount of alcohol that's been consumed, and the effect of the second factor, in this case the level of activity of the Wii game, and also their combined effect or the interaction effect. So when we have more than one factor or independent variable, we just get a between groups variance subdivided up between the main effects and the interaction effects. So when we do a one-way ANOVA, or one-way between subjects ANOVA, we get 1 F ratio. But now we're going to get 3 F ratios in this between subjects factorial ANOVA. So when we do this in SPSS, you get a table like this. So there are 3 rows that we need to pay attention to. One of them shows the main effect of activity, just the level of activity on its own. The main effect of drinks is the number of drinks the person had, and the interaction effect. The F ratio is taking the mean square of the effect and dividing by the mean square of the error. So the F represents the ratio of the effect to the error in the model. So we've got when we look at this table, we can see that we've got no significant effect on activity, as the significance value for activity is 0.062, which is above the alpha level of 0.05. There is a significant effect of drinks on accident severity, as the significance value of drinks is 0.000, which is below the alpha level of 0.05. And there is a significant interaction effect of drinks and activity on accident severity, as the significance value of this interaction is 0.011, which is below the alpha level of 0.05. What about the main effect of alcohol or drinks? So what does it mean to say there's a main effect of alcohol or drinks, which we found was significant? Well, imagine if we had not measured activity, or in other words, we had lumped together high and low activity together. And so all we know is that we had a bunch of people who either drank 0, or they had 2 drinks, or they had 4 drinks, and then they injured themselves playing the Wii game. And they're in the boxes that you can see. So all the people who did not drink were placed in this box. And the same was done for all the people who drank 2 drinks, and the same also for those who drank 4 drinks. And the numbers that you can see are their accident severity scores. Then we calculate the mean accident severity in each of those groups, or each of those boxes. So the main effect is like doing a one-way ANOVA on these 3 means to test if these 3 means are different from each other. So what you might find is that there is a significant main effect for alcohol on injury severity. And this is how you'd write up this particular main effect in the results. So what does that tell us? What that tells us is that the three means are different from each other. We don't know which means are different from each other, so we'll have to do some post hoc tests there, but somewhere one mean is different from it, at least one mean is different from another. So looking at the graph, it becomes pretty obvious where the difference is, but we would need to do some formal tests to check this out. So accident severity seems to increase with the number of drinks of alcohol. And it looks like, just from looking at this graph, that the increase in severity occurs after 4 schooners. So what does it mean when we're looking at the main effect of activity? Well, imagine again if we had not measured the number of drinks, or we'd just lumped the 0, 2 drinks and 4 drinks in all together, so we weren't that concerned about the drinks that they had. So all we know is that we have a bunch of people who play either low activity or high activity on their Wii console, and that they've injured themselves. So all the people who played low activity games were placed in this box, and the same was done for all those who played high activity games. And the numbers that you see in each box represent the accident severity scores. Then we calculate the mean of each group. So when we're looking at activity, the F ratio would tell us that there's no significant effect. And this is how you might write up this particular main effect in the results. So it becomes pretty obvious that there's no difference in accident severity scores across low and high Wii activities. You can see this as the 95% confidence interval bars overlap. This is also reflected in the non-significant main effect of activity. So you may recall with a one-way ANOVA that because there are more than 2 groups, we need to do analytical comparisons when there is a significant effect in order to establish which groups differ from which. The same applies in a factorial ANOVA. When there's a significant main effect that involves more than 2 levels, as is the case here for alcohol levels. Because there's a main effect of alcohol, and alcohol has more than 2 levels, in other words it has 3 levels actually, we need to request post hoc analyses to pinpoint which level of drinking differs from which. There are also a number of analytical comparisons available as post hoc tests. They're like t-tests, except they use the mean square error from the full factorial ANOVA. However, this is only appropriate when you've got homogeneity of variance. Now, so with a satisfactory Levene's test, the easiest way to do this is to request main effect comparisons as I did previously when doing my point and click in SPSS. The Shadak test is the preferred option as it's a slightly more powerful version of the Bonferroni test, which is the most, most general of the tests available for analytical comparisons. So if you do not have homogeneity of variance, then it's necessary to choose a test that can be used with unequal variances. All of these comparisons have an adjustment that can be used to control for family-wise error. So the comparisons here, using the Shadak adjustment to control for family-wise error across the tests, tell us that there is a significant difference between 4 drinks and 0 drinks. 4 drinks has a higher mean injury severity rating than 0 drinks, and it's significantly higher. There's a significant difference between 4 drinks and 2 drinks. 4 drinks has a higher mean injury severity rating than 2 drinks, and it's significantly higher. There's no significant difference between 2 drinks and no drinks. Note that we also focus on the main effects and their comparisons when there is no significant interaction. In this case, because there's a significant interaction, these main effect comparisons could be misleading, and as a result, they're of little further interest. Now in the SPSS output, it was clear that there was a significant interaction. Now you could look for this interaction in 2 ways. Firstly, let's have a look at the effect of activity at each level of alcoholic drink. So when there's 0 drinks that are consumed, what's the effect of activity on injury scores or injury severity? You can see that accident severity is similar when there are no drinks that have been drunk. What about when there's 2 drinks that have been drunk? You get a similar result, a similar very small difference in accident severity between the 2 levels of activity, high and low. So when there's no drinks and when there are 2 drinks that have been drunk, there sort of isn't an activity effect on accident severity. What about when there are 4 drinks? You get a bigger difference between the activity levels, or you get a bigger difference in accident severity. And this is where the interaction is likely to be. So there was a significant interaction between activity levels and the number of alcoholic drinks on accident severity. And this is how you would report that significant interaction. At 4 drinks, we see an effect of activity because the accident severity is much higher for high levels than for low levels of activity. So at 4 drinks, you get a pronounced effect, an increase in the accident severity in high activity games compared to low activity games. Not much difference when there's 0 drinks or 2 drinks consumed, but it kicks in for high activity at 4 drinks, but not for low activity games. The second way you can look at this is, so we've looked at activity at each level of alcohol, but we could do the reverse and look at alcohol at each level of activity. The effects of alcohol in the low activity, the line is pretty flat and suggests that alcohol in the low activity pretty much has no effect. But if you look at the high activity Wii games with low doses or 0 or 2 drinks, there's not much, it's pretty flat. But when you increase to 4 drinks in the high activity game, there's a spike in accident severity. So that's what an interaction is. It's the extent to which differences in factor A are the same at each level of factor B. So if I wanted to look at this in terms of bar charts rather than line charts, well, the same principle applies. Not really an activity difference for 0 or 2 schooners, but at 4 schooners you get that difference. Now there are different types of interactions, such as ordinal and disordinal interactions. The type of interaction has implications for the main effects. Please see your readings for this week for further explanation around this particular topic. So at this point, what do we know? There's a significant main effect of alcohol, with Shadak pairwise comparisons indicating a significantly higher injury for 4 drinks compared to 2 drinks or no drinks. There's no significant main effect for activity. And there's a significant alcohol by activity interaction. We also know that an interaction takes priority because it qualifies or even invalidates the main effects. What we don't know is exactly what's going on in the interaction, even though the graph gave us a pretty good idea.